And I invite forward our next speaker, Bokowa. Anna's been on this field for quite a number of years, 23 years of technical experience in odor assessment, including odor sampling, odor evaluation, ambient odor monitoring, material testing, etc. Lots of experience here. She's authored quite a few papers on the subject as well. So I invite her forward to speak to us about challenges when sampling for odor at wastewater treatment plants.
Hello, everybody. The title of my speech is Challenges when Sampling for Odors at Wastewater Treatment Plant. But it's not about the wastewater treatment plant, it's also about the sampling at the area sources. This speech is based on one case study done at the wastewater treatment plant in Ontario. I don't know how many people are familiar with odor sampling. That's the reason in the beginning of the speech I would like to mention about the principles of the odor sampling, how this sampling is done. I will also mention some standards and guidelines for odor sampling. And then I will introduce several commonly used methods to estimate the odors from the area sources. And then I will introduce my case study, and I will end the presentation with conclusions. Why it's so difficult and why we are ending up with the different results when we assess the odors at the wastewater treatment plants or any facilities where the majority of the sources are either area sources or fugitive sources. There's a simple question because there's a standard procedure for evaluation of the point source, standard procedure for assessment of the odors from the point sources. But fugitive sources or area sources are always complicated. And basically, every time we do the sampling at these sources, there will be just the estimation. And by doing this presentation, I will show you the results, how the results might be different if, and it will depend on the methodology you choose. Sources at the wastewater treatment plant can be point sources, area sources. Area sources can be categorized as active sources, sources with noticeable flow, like aeration tanks. Passive surface sources without flow, like primary tanks, or combination of the mixture of passive and active. For example, for different conditions, when the aerations are on and then the aerations are off, then there's a mixture of the sources. Fugitive sources, we call it any open doors, trucks waiting to load or unload the material. How to measure the odor, then I think most of the people are very familiar how to measure the odor, but I will briefly introduce to the sampling procedure for the people who are not familiar with the sampling. Basically, it's a collection of the samples, odor samples for total odors at any source, can be point source. For the point source, we use the dilution equipment. Samples needs to be diluted on site with nitrogen. For the area, I will mention later on. But after collection of the samples are evaluated by dynamic olfactometry in the lab for odor detection threshold values. With the combination of the volumetric flow rates measured or designed, we come up with the odor emission rates, which are used in the dispersion modeling to predict our off-site odor concentrations. There are several standards. European standard EN 13725 developed in 2003. Right now it's under revision. There are several committees for different sections. I think it will be released soon. That's right?
I think in a couple of years.
Oh, yeah. Australian, which is exactly as European standard, it always bothers me why it was developed in 2001, but we haven't heard, but we heard about the European standard. In Germany, there is a VDI standard for the sampling. Because European and Australian standards, they mention the sampling, but they are not very detailed in the procedures. German VDI is much better. In United States, it's even worse because there's ASTM 679. I was a member, I was the chair of the Committee for Standardization in the US. We tried to develop the methodology standard guidelines, but after so many years, probably 6-9 years, I think it's still draft, and I think everybody are using right now the European standard. In Canada, we have Ontario Source Testing Code, Method ON6, determination of odor emissions from stationary sources. Then all these all these standards or guidelines, they mention different procedure for different types of the sources. Still, there is procedure method used by most of the consultants, a flux chamber method. Personally, I did a lot of studies in the past, and they confirmed that the emissions obtained by the flux chamber method, they underestimate the emissions. I think when I talked to the colleagues in Europe, they came up with the same conclusions. Anyway, the methodologies used for estimation of the emissions from the area sources, there are different methods, like a flux chamber, what I mentioned, wind tunnel, there is a static hood, or backup calculation with together with the air dispersion modeling. There's a new method based on the principle of mass transfer from liquid and gas phase, which was recently introduced in 2015 during the AWMA conference, and you can I can refer to that paper later. I think it's described in one of the papers. Explore on approach to determine odor emissions from water surfaces. Then if you have any questions about that methodology, then I will refer to that paper. Going back to the methods for area sources, going back to the flux chamber method, I'm not sure how many people are familiar with that, but it's a floating device, and nitrogen is used as a sweep gas. Samples are collected at the outlet of the chamber. Usually 3 samples are collected, which might be also diluted on site using the dilution sampler. It's important to purge the system before the collection of the samples, just to make sure that because by placing the flux chamber, you cover first the ambient, then you have to replace that with the nitrogen. And nitrogen flow together with the odor detection thresholds values, which you obtain by doing the evaluation in the lab, then we calculate the odor emissions rates for this surface. Another method is wind tunnel method. It's a similar method, but the air is used as a replacement of the nitrogen. You can control the different speeds for that method, it's very hard method. It's much better method than the flux chamber, but for that method, I think it's very difficult to get the clean air because you either need to very long tube to make sure that your air is clean. Then I don't see many people using the wind tunnel. Another method is the backup calculation used with dispersion modeling. It was developed a few years back. Then basically is based on the ambient concentration. You collect the samples downwind from the area source, and using the dispersion modeling, you predict the emission rates. For that method, the large number of samples are required, and also you need to make sure that some of the area sources, different types of the sources, are not in line for specific wind directions. That's the setup for the backup calculation, means ambient sampling, and later on use the dispersion modeling. The method what I mentioned before, the new method based on the mass transfer from liquid to gas phase, it's also it's based on the collection of the samples using the flux chamber, but you are not using the nitrogen flow for the calculation of the emission rates. You use the model to calculate the coefficients factors, but again, that method is fully described in the paper Explore an Approach to Determine the Odor Emissions from the Water Surfaces, and was presented in June during the AWMA conference. For my study, I used different methodology, flux chamber, wind tunnel, which was used only for partially because it was difficult to use for all the area sources, but then later on we, based on our previous experience, we came up with the factor. We multiplied the emission rates by the factor, the difference between the flux and wind tunnel based on the studies done before. For the mass transfer method, we use the flux chamber. Again, for each for each surface source, we used 2 locations. We collected 3 samples. There were also 2 conditions for some of the tanks. We didn't use we tried to collect the samples for the backup calculations, but later on we figured out that for the specific wind directions, we couldn't really know which source we are measuring. Then we skipped that method for that project. In addition, we also collected the samples at the sensitive receptor downwind from the facility, basically in front of someone's houses, because people were complaining. And also for each sensitive receptor, we collected 1 upwind location. At each location, downwind or upwind, we collected 3 samples. And the sampling time was 10 minutes for each sample. We used the 8-screen panelist. That's a setup for the ambient sampling. Then sample were, after the collection, were covered in dark color bag just to prevent any photochemical reaction. And evaluation was done within, I believe for that case, 12 hours after collection by dynamic olfactometry and screen panelists using the EN 13725, with one exception that each sample was introduced only once to the panel members, not 3 times as required by the EN standard. That's our setup. Okay. The results. When you look at the results for the sensitive receptor 1, condition 1, we measured 13. Predicted by measuring by the flux chamber was 2. Predicted by the wind tunnel, we multiply the flux by the wind tunnel by a factor of 6. Predicted by the new method, we ended up with 14. The same for the sensitive receptor 2. The measured ambient concentration was 10. The flux chamber was 1. Predicted ambient concentration based on the mass transfer method was 14. For the condition 2, which was higher, the sensitive receptor, I think it was 2, was 69 versus 63, but 7 only for the flux. The same for the sensitive receptor 3 was measured, was 55, 5 for the flux, and on the mass transfer, 45. The condition 2 sensitive receptor was a little bit off, but still with the factor of 2 for the model, was 138 measured, 73 for the mass transfer, and 14 only based on the flux method. Then my conclusions are that the backup calculation was not used for that study. Then we don't have any numbers for that. There is a good correlation between measured ambient concentration and concentration obtained by mass transfer method and wind tunnel method. But again, wind tunnel method is just the estimation based on the factors. Flux chamber method underestimates the odor concentration. Therefore, when assessing the odors from a wastewater treatment plant or any surface areas, we should really consider which methodology we'll be using, and it's very important, especially when the complaints occurs. Thank you.
Thank you very much. Time for questions from the audience. Anything at all?
That was easy.
First up. We have two.
Okay.
I was just wondering that you mentioned Flux chamber is the most popular.
Oh yeah, sure. Sorry, I need to put my glasses on.
You mentioned Flux chamber is the most popular sampling method. So I just wanted to see what's the reason of the most frequent used sampling method. Is it because it's like a cheaper method, or what's the reason for that?
Well, I think the flux chamber is still a recognized method. That's the reason people are still using, because it's a recognized method. But I did several studies in the past, and all like I have colleagues in Europe. They did separate study all the time. People, and they're ending up with the lower numbers when they use the flux chamber. But I think it's the most common right now because it's approved method, unless someone will say that it's not the right method. And we know that's not the right method.
Thank you very much. We'll move on to the next speaker. Thank you.